Hello students, in this video we'll learn about some terms in probability and we'll also do some examples related to probability or how to find them. Now let us look at some terms. Now a trial. What is a trial? A trial is an action which results in one or several outcomes. Now for example, when you toss a coin, you get outcomes as heads or tail. That is an action performed to get the outcomes of the action. Now, let us see another example, that is rolling of a die. When you roll a die, you get your outcomes to be 1, 2, 3, 4, 5, 6. That are the faces of die, right? Faces of the die that we have. So whenever you roll, you'll end up having one of these face, and the face will have a number written on it. That is the number of dots would be made on it, right? So that would be an outcome of rolling of die, and such actions with outcomes are called as trial. Now event is the event of for an experiment is the collection of some outcomes of the experiment. That is, it is a trial done to get a particular outcome. For example, when you toss a coin, now you're tossing the coin to get heads. Now you may toss a coin a number of times and you will get you'll get heads in between them. So you will just make a list of whenever you have got the heads, and you may write the number of times you have got the heads. Now that is your event. That is, getting your head in the trial is your event. Now for example, when you roll a die to get an even number, now here your outcomes would be 2, 4 and 6. But your trial, that is, when you roll a die, your trial would be all these 6 outcomes. That is 1, 2, 3, 4, 5 and 6. So the outcomes of your trial remains the same as the basic one, but the outcome of event changes depending on what you want your outcome to be. Now let us finally move on to our formula which helps us find the probability of a question. That is that we call as experimental or empirical probability, right? So here our n is given to be as our total number of trials. So that is, n is our total number of trials, right? So now here we are given the formula when we have flipped the coin and we want our outcome to be tail. So the probability would be number of times a tail come up. So I can write it in a more general form, that if we have done a trial, so number of times a outcome has come up divided by total number of times the coin is tossed, or the total number of times the trial is occurred, which is given as n over here, right? So this may be called as a general formula that we'll use in all our questions that we do in this chapter. So now let us note that empirical probability keeps changing depending on the number of trials and the number of heads obtained in these trials. Now, empirical probability, this is very obvious that it will keeps on changing depending on the number of trials that we have performed, that is at n, right? And also it will keep on changing on the based on the number of heads that we have got, even if our probability is of tails, but still it still depends on the number of heads, because we know that the more the number of heads we'll get, lesser would be our tail. So that is why the outcome are dependent on another. So here also we can see that whenever we increase the number of trials, so the outcome or the probability will keep on changing, and it will also keep on changing based on the number of times some particular outcome has come. Now here also, and the second point, we can see the empirical probability depends on the number of trials undertaken. That is the same as above, that number of times we have done the trial or performed the action, and the number of times the outcome you're looking for has come up. That is the number of times that a tail has come up in this example, right? So now that we have learned the formula, let us hop on to the questions and let us see how this formula, the general formula, is used. Now, let us see our example number 1. So here, now let us see our example number 1. Here, a coin is tossed 1,000 times with the following frequency. Now, 1,000 times a coin have been tossed, and we have got these frequencies. Now, we have to compute probability for each event. So, first of all, let us compute the probability of event for heads, right? So, we'll have number of times heads have come up divided by total number of trials, right? So we have 455 divided by 1,000, and which will come out to be 0.45 and 5. Now similarly for tail, we'll have number of times tail have come, right? And divided by n, that is total number of trials. So we'll have here 545 divided by 1,000, which is equals to 0.545, right? So this is how we find our probability by using the formula that we have just learned. Now you may notice here that when you add these two, that is 0.545 plus 0.455, then when you add these up, you'll see that it will give us our number 1. That is the total probability. That is the only, that means that these are the only possible outcomes that can occur. And this is very true. That is, whenever we flip a coin, we can either get heads or we can get tail, right? Now let us move on to example number 2. In this question, we're given 2 coins and they're tossed simultaneously 500 times, and we get 2 heads, 1 head, and no head. Now we have to find the probability of occurrence of these events. Now let us see the outcomes that we can get. That is, we can either get 2 tails, we can get 1 tail, 1 head, 1 head, 1 tail, or we can get heads or heads. So these are the outcomes that we can have. And now we are given the 2 heads, that is this, or we're given 1 head, that is these 2, or we're given no heads, that is this. Now we have to find out the probability of these events. Now let us find out for the probability of 2 heads. So we'll again have the number of times it has occurred, that is 105 times, and our n here is 500 times, right? Because the 2 coins are tossed 500 times. So we'll have 500, and when we'll divide it, we'll get 0.21. Now similarly, for probability of, I'll just write here 1 head. Probability of 2 heads, right? Probability of 1 head would be 275 divided by 500, which is 0.55. Then we have probability of no head, and that is equal to 120 divided by 500, which is 0.24. Now you see that as we have got all these 3 probabilities. Now here also, if you add these all up, let us add these up. 1.21 plus 0.24, which will give us 54, and then we have 0.55 plus 0.45 and we'll get 1.00. Now you can see here that our total probability is coming out to be 1. That means these are the only 3 cases that are possible, and these are very obvious since all our outcomes are being involved in these 3 outcomes that are numbers given, right? So that is how we take out the probability in this case. Now let us move on to our example number 3. Now here a die is thrown 1,000 times with frequencies of our outcomes as 1, 2, 3, 4, 5, and 6 in the given table. Now we have to find the probability of each outcome. Now similar to the coin question, here we are given n to be 1000. So now let us find out the probability to get each of these faces or each of these outcomes. So a probability of 1 would be 179. That is the number of times 1 has occurred divided by n. That is 1000. So we'll get 0.179. Similarly, probability of getting 2 is equals to 150. That is the number of times 2 has occurred divided by 1000. That is 0.15. And we can take out the other probabilities like that only. For 3, we have 157 divided by 1000. We get 0.157. And for 4, we have 149. That is 4 has come out 149 times, and 1000, this is 0.149. Now our 5 is equal to 0.175, right? Because 175 divided by 1000, and our 6 would also come out to be 0.19. So these are the probabilities of each of these outcomes that we can get in a die. And here also, if you add all these up, you'll get 1. That means that these are the only possible outcomes that could come if you roll a die. Now let us move on to our next question. That is our example number 4. So now in our example number 4, it is given that one page of a telephone directory, or that is on one page of a telephone directory, there were 200 telephone numbers, and the frequency distribution of their unit place digit is given like this. Now, a unit place digit means the last number of the telephone number. That is, if this is our telephone number, then our unit place digit would be 3. That is the last number, right? So we are given a page of the telephone directory, and there are 200 telephone numbers, and the frequency of the last number is given like this. Now, without looking at page, the pencil is placed on one of these numbers. That is, the pencil is placed now placed randomly, and the number is chosen at random. Now, what is the probability that the digit in its unit place is 6? That means this digit should come out to be 6. Now, we know here that we are given 200 telephone numbers. So that means at n, that is the number of trials, or we can say the number of times the maximum number of times the event can occur is 200, right? So our n is 200, and then the number of times 6 can come is, this is a 6, and the number of times it has come is 14. So we have our frequency to be 14. So now to get P6, we have to write the number of times 6 has come. That is, it has come 14 times divided by 200, and which will give us answer as 0.07 as our probability. Now you can see how little the probability is of getting the number involving 6 as its last digit, right? So now let us move on to our next example. That is our example number 5. Now in this question, the record of a weather station shows that out of past 250 consecutive days, its weather forecast were correct 175 times. So we have been given 250 consecutive. So the weather forecast has been giving out the readings or the weather forecast for past 250 days. That is 250 weather forecasts have been delivered. So we can say our n is equals to 250, and out of these, only 175 were correct. So now, what is the probability on a given day that it was correct? Now, the probability that it is correct would be the number of times the probability has occurred. The event has occurred. That is 175 times it has occurred, divided by the total number of times the trial has happened. is 250, and this will come out to be our 0.7. So this is our probability that the weather forecast on a day would be correct. And the next is that the probability that it was not correct. Now to get it, we have to know the number of times the forecast is not correct, and we'll find it by subtracting the correct ones from the total, that is 250 minus 175, and we'll get our 175, right? So we can easily find the P not correct as 75 divided by 250, which will give us 0.3. This is how we find our probability in these particular questions, right? So let us move on to our next question, that is example number 6. Now in this question, a tire manufacturing company has kept a record of the distance covered before a tire needs to be replaced. So this is a tire manufacturing company, maybe for a car, maybe for a motorcycle, but that is not our concern. Our concern is the table given. That is, the table shows the record of 1,000 cases, and the 1,000 cases are of the case that is of the record of the distance covered before the tire needs to be replaced. Right. So here is the record. We have the frequency, that is the number of tires that could do well. Less or have been exhausted in less than 4,000, that is, they need to be 20 tires have to be replaced in while when they have traveled distance that is less than 4,000 kilometer. Then we have the range of this, then this and this. Now let us see what all has been written in questions. Now, if you buy a tire of this company, now we are going to buy the tire of this company, what is the probability that it will need to be replaced before it has covered 4,000 kilometers? Now that means our tire has been exhausted before 4,000 kilometers. So that means we have to use this number, right? Because these are the number of tires that has been exhausted or needs to be replaced before 4,000 kilometers. So we'll write P less than 4,000. Right? So here we have our event. Our number of times it has happened is 20. Upon total number is our N is 1,000, because it is given that it is the result of 1,000 cases. So it is divided by 1,000. Now we will get it to be 0.020, or maybe not. So that is our answer. Now our first part is done. Let us move on to our second part, that it will last more than 1,000 kilometers. And to last more than 1,000 kilometers, that means more than 9,000 kilometers, right? So that means not this, because it is just 4,000 to 9,000, not greater than 9,000. So we'll have this one because it is greater than 9,000. So we have 325 tires, and also even these are greater than 9,000, right? So we have these two frequencies as we are getting for the tire which can travel greater than 9,000. So we can add these up. So the total number of times our outcome has come in this case is equals to 325 plus 445, and when we'll add it up, we'll get 770, right? And now what you have to do is to get the probability greater than 9,000. We have to do 770, that is the number of times our outcome has come, divided by the number of trials. And you know what the answer would be. As you can calculate it from here, it is 0.77. So this is our probability that the tire will run for more than 9,000 kilometers. The next is it will need to be replaced after it has covered somewhere between 4,000 and 14,000 kilometers. So that means our bracket now comes for greater than 4,000, that is this, and 14,000, so this. So we have these two in our bracket. So we'll add the number of times the outcome has come is 210, 210 plus 325, and which will give our answer to be 535. And now the probability of 4,000 to 14000, 14,000 is 535 divided by 1000, which is equals to 0.535. Now these are the probabilities for all these three cases that have been asked in our question. Now let us move on to example number 7. Now in this, the percentage of marks obtained by a student in a monthly unit test are given below. Now these are the percentage of marks obtained and these are the unit tests, that is 1, 2, 3, 4, 5. Now based on this data, you have to find the probability that the student gets more than 70% marks in a unit test. Now these are the marks given and we have to have more than 70%. So let us see when have he got more than 70%. First of all, he has got it in unit test 2. So let me just write it. So we have more than 70%. So we have it in unit test 2. Then we have it in third, right? This is more than 70. Then this is more than 70. And fifth. So the number of times the event has occurred, number of times he has got greater than 70 is equal to 3, right? And our n is number of times the unit test have happened is 5. So our probability greater than 70 it would be 3 by 5, which will come out to be 0.6. So this is our probability that the student will get marks more than 70% in the unit test. Now we'll do example number 8. In this example, an insurance company has selected 2,000 drivers at random. That is, they do not have any preference of one driver over another, and they have just selected out in random. Now, in a particular city, to find the relationship between age and accidents. Now, they want to find the relationship between age and accidents, and they have found it that they have recorded the data about these, and we have to find the probabilities of the following event for a driver chosen at random from the city. Now, now we have to find the probabilities of these events that have been asked to us. So first is our driver being 18 to 29 years of age and having exactly 3 accidents in 1 year. So first of all, let me write my n. N is 2,000 because we have 2,000 drivers. That is the number of our total number of trials could be said to be 2,000 times. So now let me see, now here let us see our outcome. That is, our age should be 18 to 29 and it should have, he or she should have exactly 3 accidents. So in this bracket are 18 to 29 and exactly 3 brackets. So we have 61 over here. So 61 divided by 2,000, right? And we'll get our answer to be 0.0305, right? So this is how we found out the probability that a person, when we have heard of accident, then a person would be of 18 to 29 years of age and he would have had 3 accidents. So now let us move on to a second part, that is our driver is chosen, which is chosen is between 30 to 50 years, that is this. So now in this question, we have to find out that our driver is being of age 30 to 50 years and they have more than one or more accidents. right, in a year. So now we have 30 to 50 and we have 1, that is this, and more than 1. That would mean that we have to add all these accidents that have been done by this age group. So now adding them, that is a number of times the event has occurred or our outcome has come is equals to 125 plus 60 plus 22 plus 80, which will give us 225 as a number of times, and our n is 2000. So our probability of 30 to 50 years with more than 130 uh, 30 to 50 years with more than one accident would be 225 divided by 2000, which will give our answer to be 0.1125. So this is our probability that such a driver is being chosen. Now a third part of this question is that a driver is chosen that is such that he or she has no accidents in 1 year. So no accidents in 1 year. So that means the sum of all the no accidents. There is no limit on age group, right? So we'll have our number of times our favorable outcome has come, or our event has occurred. All the same thing, favorable outcome has come is equals to 400 plus 505 plus 360. Now when we add these up, we get 1, 2, 6 and 5. So this would be our number of times. So when we'll take out the probability would be 1265 divided by 2000, which will give us 0.6325. And this would be our probability of the particular situation that we have been given. So that is how we do such questions. Now let us move on to our example number 9. Now in this example, consider a frequency distribution table which gives the weight of 38 students of a class. Find the probability. Now first of all, we are given a distribution table. Now this is a table. This is giving us the weight of 38 students of a class. Now there are 38 students in total and this is the weight category in which they fell. Now we have to find the probability of a student that lies in this class and that lies in the interval 46 to 50. That means this interval. So we have the number of students as 3. So our probability that is our number of our event that is 3. So our probability 46 to 50 is equal to, that is this weight category would be 3 upon n. N is 38, right? Because the number of students is 38, that is the total. So we have 3 by 38, which is 0.079. So this is the answer to the first question, first part. Now let us see the second part. Now in here we have to, in this context, we have to give a event. We have to give a event that have probability 0 and other event that have probability 1. So first our event for probability 0. Now if we say that, let us find out the probability for 0. Now if we say that we have to find the probability of number of students that have weight less than 30. As we can see, the minimum number of weight is, the minimum weight of a student is 31, right? So the number of students with weight less than 30 is equals to 0, right? So our probability would come out to be 0 by 38, which is 0. You can choose any other example as you like. You may choose that the number of students with weight greater than 75, or maybe 76, right? So here also we have no student as such, so it is 0. So similar, now the probability would also come out. So that is how we get our 0. Now to get the probability of 1, we can say that, you can see here that everyone has weight greater than 30, right? So probability of weight greater than 30 would be equals to all the 39 students is all fall in this category. So we would have 38 students, right? So 38 divided by 8, we'll have 1. So this is this is a probability of the students having weight more than 30, and the probability that will come out to be 1. That is always true, right? So let us move on to our last question, last example. That is our example number 10. So in this question, we have been given, we had said that 50 seeds were selected at random from each bag of 5 seeds. Now we have 5 bags. Now 50 seeds were selected at random from each of the 5 bags of seeds. So these are the 5 bags of the seeds, and 50 seeds were selected from each. So right here we have selected 50, 50, 50. And now these bags have been kept under the standardized condition favorable to germination. Now they have been kept favorable to germination so that the seeds could germinate and make a plant. Now after 20 days, the number of seeds which had germinated in each collection were counted and recorded. So this is the record of from each bag how many seeds have been germinated, or how many seeds have been grown into a shoot, right? So now here let us find the probability. So in our first part, we have been asked to find the probability of germination of more than 40 seeds in a bag. Now let us see where have we got more than 40 seeds. So first is this, in the bag, in bag 2 we have got more than 40, then we have in 3, and then we have in 5. So we have our number of times the event has occurred is 5, right? Actually it's 3, right? Because the number of times the event is occurred is 3, while total number so that is a total number of times we have got 40 greater than 40 seeds in our bag. So this is 3, right? The favorable number of outcomes are 3, and then the number of that is the total number of trials would be considered to be 5, right? So our n is 5, so we can get probability of greater than 40 seeds is 3 by 5, which is 0.6, right? Now in next part, there are 49 seeds in a bag. So now can you see any of the bag having 49 seeds? Well, there is not any. So the number of outcomes here would be 0, right? So the event has occurred 0 number of times. So the probability of greater than 40 would be 0 divided by 5, which is 0. And similarly here, in the next question, we have more than 35 seeds in a bag. Now here we can see that more than 35, all of these are having more than 35 number of seeds that have been germinated. So we can easily write here 35, that is P more than, or it is P more than 35 is equal to 5 divided by 5, that is all by all, that is 1. So that is the probability of selecting a bag with having more than 35 number of seeds that were recorded is 1. That is, it is always true, and you will always get one such a bag. Now we have learned in this chapter a lot of things about how to find the probability and why should we study it, what is the use of probability, etc. So now let us do a quick revision of what all we have learned. So the concepts that we have learned is an event for an experiment is a collection of some outcomes of the experiment, right? It is a collection of the desired outcomes that we want. So now, and the next thing that we have learned is the formula of how to find the probability, and that is given by the number of times our event has occurred divided by total number of times the total number of trials that has been done. So in tossing of coin, we can say that, and if our desired outcome is tail, so we can say that number of times the tail has come up divided by total number of times the coin is tossed. Now the third part is the probability of an event always lie between 0 and 1. 0 and 1 inclusive means that it could be 0 and 1, right? So 0 is when impossible, right? Our event is impossible. And 1 is when it is always true, right? So it is always impossible. For example, sun rises from the west. Now the sun never rises from the west, so hence our probability of the such a event is 0. While while if I'll say that sun rises from the east, now sun always rises from the east, so our probability is 1, and hence we can and the rest all the probabilities of any event would occur between 0 and 1, right? So this hence we conclude with our chapter number 15, probability.